Namaste, good morning my dear students. So again today also we are continuing the solution chapter. So in this solution chapter means in the last week also we have started the Henry's law and Rolle's law. So whichever we are studying this ideal and non-ideal, it is related based on the Rolle's law. So means based on the vapor pressure, if you remember this one, because Henry based on gaseous and whereas Rolle's is based on the liquid vapor pressure. So in the last class we have studied that ideal which obeys Rolle's law and non-ideal which do not obey the Rolle's law at all concentration and temperature. One thing. So I said that in the non-ideal again there are two types. What? How means? Okay. In the non-ideal we are classifying the non-ideal compounds based on the as we did in the ideal. So in the ideal we are saying that Rolle's law is obeyed and there is no change in the enthalpy. There is no change in the enthalpy and there is no change in the volume of the solution. If two compounds we are adding A and B, that volume of that A and B, how much it is by adding those two and it remains same. So that is an ideal. Whereas in the non-ideal which we have discussed, the non-ideal solution do not obey Rolle's law and also there is no equality in the enthalpy and in the volume of the gases. If the enthalpy they may undergo change, means it's not equal, delta H is not equal to 0, it means it's undergo some changes. So even delta V means volume of the gas is undergo changes, means the change in the volume is not 0, means it is having some changes, means it may increase or it may decrease. Similarly in the enthalpy, it may increase in the enthalpy or it may decrease in the enthalpy. So based on this variation, whether it is increasing or decreasing, based on that we are classifying the enthalpy. We are classifying the non-ideal solution. In the non-ideal solution, again there are two types. Means non-ideal solution, with positive deviation is one. With positive deviation, another one is with the negative deviation. What is this positive deviation and negative deviation? Here positive is nothing but it going to undergo the change in enthalpy or positive value, means enthalpy is changing and also the volume is changing. Here negative indicates that the change in enthalpy is also decreasing, means it is in negative it is, and the change in volume it is also decreasing, means it is in the negative. So before we move to how and what is this enthalpy and all everything, so let's look at the previous one. So in the last week I explained you, while explaining the ideal I have given the graph, but at that time I didn't explain you. Why? Because so here just you can able to compare here. So ideal gas are nothing but they are having this graph. This graph is related to the ideal. So this is ideal graph. So what is here? Look here in the solution I said you XA and XB is always equal to what? XA plus XB. What is this XA plus XB? XA is nothing but number of moles of component A plus number of moles of component B. If the two components are having the mole fraction of that together, all the component is always unity, because in the last solving problem we have observed. So based on that, XA plus XB is always unity. So looking at that, you just look here. So this graph is going to represent about the ideal solution. So ideal solution in this graph, the x-axis shows by the mole fraction. Here x is nothing but mole fraction, whereas y-axis represents the vapor pressure. Similarly, I have observed the same thing. In the positive deviation, I have taken the mole fraction along the x-axis. Here also it is along the x-axis it is mole fraction. Along the y-axis, I have taken vapor pressure. There is no change in each of the graph. Initially it is. Can you see here? Whatever I have written, x0, xa, bc, everything is same. So look here. Here I have taken xa is 0. Xa is 0 is nothing but what? here mole fraction of component A is 0. It means that mole fraction of component B is totally 1 because together it should be a unity. Here XA is 0 means XB is 1. As we move from left to the right, the mole fraction of XA increases, XB decreases. How means at the end we are having XA is equal to 1, XB is equal to 0. Can you see here? Initially XA is 0, as we move XA becomes 1 and XB from 1 to it is going to reach the 0. Why? Because together they should have the value unity, one condition, and the same condition whenever we take a middle point, it means that together their sum should be unity. This is you should have in your mind. We are not going to calculate anything, just for our theoretical part, for our understanding. To differentiate the positive and negative, you need these concepts. That's all. So look here I have written some graph. So as at this left, if we draw the potential difference, means vapor pressure, particularly vapor pressure of component A is increases here, and here also from potential difference, I mean vapor pressure is also increasing here because according to the y-axis vapor pressure is increasing even in the component A and B. Here as the A, can you see it? As the mole fraction is increasing, vapor pressure is increasing. Here XP is 0 here, XP is 0. As the mole fraction is increasing, can you see it? Mole fraction is increasing, the vapor pressure is also increasing. So it means as the number of moles are increasing, vapor pressure also increases. It will happen even in the ideal, non-ideal, even positive and deviation. Same thing is happening. XA is 0, XA is increasing as increasing the mole fraction. XP here 0, here it is. As the XP is increasing from right to the left, vapor pressure is also increasing. Whichever I have drawn in the first, everything is same in the ideal and these two non-ideal. Keep in your mind. So now I am going to explain it. Okay. So in the ideal solution, I hope you understand. XA is 0 and XP is maximum. Here XP is minimum, XA is maximum. Together it should be one thing. As the mole fraction increases, vapor pressure of that corresponding, means if it is A, it may be a B. As the mole fraction increases, that corresponding vapor pressure also increases. Are you getting this part? It's not important, don't get confusion. Why I am explaining one part? Formally for to differentiate what is positive and negative. Are you getting this part? So the same concept here, together the mole fraction of component A and B at some vapor pressure, means if this is the vapor pressure of component A, PA, this is vapor pressure of the component B. Together we are drawing and joining this point. This is called as total vapor pressure of the component. Total vapor pressure of the component A and B. So same thing here also we have did the same thing. There is no change. But what happens means here in the ideal solution, we are going to observe the same thing as we are appearing in the graph. Whereas in the non-ideal solution, this should happen in the same manner, but it is not happening because ideals are going to obey Rolle's law. This is according to the Rolle's law. Whereas in the non-ideal, they are not obeying the Rolle's law. What the Rolle's law says that the delta H and delta B should be same even after forming or mixing the two components. Whereas in the non-ideal, they are not obeying the Rolle's law. Means they are undergo change in the temperature or change in the enthalpy. It should undergo both. Enthalpy also changes and vapor also, temperature also changes. So here non-ideal solution, there are two types. One is non-ideal solution with a positive deviation, that is one. Another one is non-ideal solution with a negative deviation. These are the two classifications in non-ideal solution. In the non-ideal solution, can you see here? Here everything is same. XA is 0 and it is increasing 1. And when XA is 0, XB is 1. As we know, XB decreases when XB becomes 0 and XA becomes 1. So same thing here, XB is 0 and as the XB increasing, vapor pressure increases. From 0 to when we move XA towards 1, then vapor pressure is increasing. The same thing. Here, the positive deviation is nothing but whichever we have drawn this graph. Means as the XA increasing to increase the XB, this vapor pressure is is this is according to the Rolle's law. Whereas it undergo the positive deviation means this value is going to increase slightly. Means I am going to draw the graph slightly greater than or above this lines, above this dotted line. Can you see here? This is called as a deviation. Deviation. If the lines are as I have shown here, if it is obeying the same lines are observing the graph, then it is said to be a ideal solution. It is said to be an ideal solution. If the graph is bending, means it is deviating. If it is deviates, means it is called as non-ideal. In that deviation, can you see here? The deviated graph is above the graph. Can you see here? This is above, means the values are increasing. The values are increasing. If it is increased, means vapor pressure it is increased. If the vapor pressure is increased, then it is called as positive deviation. Here also, the graph is increases. Can you see here? It is deviating. If the graph is deviating, then it is called as positive deviation. Similarly, total pressure is also increasing. Here the total pressure is also increases. Are you getting my point? This is according to the ideal, means it obey Rolle's law. This is according to the non-ideal, whereas it do not obey Rolle's law, whereas these are undergo the deviation by positively, means the enthalpy or volume they are increasing here. That's why it's called as positive deviation. Whereas I hope you can able to judge the next one. Here non-ideal solution with the negative deviations are nothing but here the values are increasing and here the values are going to be decreasing. Means graph is coming below, means enthalpy is decreasing. Its normal value ಕಿಂತ ಏನಾಗುತ್ತೆ ಕಡಿಮೆ ಬರುತ್ತೆ. ಕಡಿಮೆ ಬಂದಾಗ ನಾವು ಅದನ್ನ ಏನು ಕರಿತೀವಿ ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಡಿವಿಯೇಷನ್ಸ್ ಅಂತ. Here it is increased, here it is decreasing. I hope we can able to understand this. The color choice is very less, that's why I am feeling a little bit difficulty to draw. This is color change, don't worry. I hope this is getting same line same graph ಬಂತಂದ್ರೆ ಐಡಿಯಲ್. ಅದೇ ಗ್ರಾಫ್ ಸ್ವಲ್ಪ ಮೇಲ್ಗಡೆ ಬಂದ್ರೆ ಡಿವಿಯೇಟ್ ಪಾಸಿಟಿವ್ ಆದ್ರೆ ಮೇಲ್ಗಡೆ ಬಂದ್ರೆ ಪಾಸಿಟಿವ್ ಡಿವಿಯೇಷನ್ಸ್ ಅಂತೀವಿ. ಅದೇ ಗ್ರಾಫ್ ಕೆಳಗಡೆ ಬಂತಂದ್ರೆ ಆ ಗ್ರಾಫ್ ಗಿಂತನೂ ವ್ಯಾಲ್ಯೂಸ್ ಕೆಳಗಡೆ ಬಂದ್ರೆ ಅದನ್ನ ನಾವು ನೆಗೆಟಿವ್ ಡಿವಿಯೇಷನ್ಸ್ ಅಂತ. ಪಾಸಿಟಿವ್ ಅಂದ್ರೆ ಇನ್ಕ್ರೀಸ್ ಆಗೋದು, ನೆಗೆಟಿವ್ ಅಂದ್ರೆ ಡಿಕ್ರೀಸ್ ಆಗೋದು. ಐ ಹೋಪ್ ಯು ಕ್ಯಾನ್ ಏಬಲ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್ ಒನ್. ಸೊ ನಾನ್ ಐಡಿಯಲ್ ವಿತ್ ನೆಗೆಟಿವ್ ಡಿವಿಯೇಷನ್ ಮೀನ್ಸ್ ಗ್ರಾಫ್ಸ್ ಆರ್ ಕಮಿಂಗ್ ಬಿಲೋ ದಟ್ ideal graph, and here positive deviations are nothing but the graphs are coming above the ideal graph, and here the ideal chances. I hope you can able to understand. By referring this one, we can able to classify the ideal and non-ideal. So here the question arises says they will ask you what is non-ideal solution. This was being discussed in the last video. Now here in the non-ideal solution, if they ask the examples, in whichever I am going to give the examples of non-ideal, those means in positive and negative. These example together it is an example for non-ideal. You should know this one. And here in the non-ideal solutions, what is this non-ideal solution means? The non-ideal solution, there are two types. One is positive deviation, non-ideal with a positive deviation, and non-ideal with negative deviation. So positive deviations are nothing but what? Here the non-ideal solutions which undergo the, obviously non-ideal solutions are do not obey the Rolle's law and they are undergo the deviation in the enthalpy, means delta H. Here delta H value in positive deviation, the delta H is positive, delta H is positive, and delta V also it is positive. How means as we added total volume, when we added VA plus VB, these are having the greater volume than the previous one. Means you can take this one, this is greater volume. The volume of total volume of VA and VB is greater. Similarly here also the enthalpy change in enthalpy is positive, it is increased. If it is increased, then it is called as positive deviation. The non-ideal solution with the negative deviations are said to be a negative deviations when the change in enthalpy is decreased, means it is negative value, and also the change in the volume, mixing of the volume is decreased, it is negative, then it is called as negative deviation. So I hope you can able to understand what is the positive deviation, what is negative deviation. Here, if the delta H and delta V remain same, if it is equal to 0, then it is ideal solution. If it is not equal, it is non-ideal. In non-ideal, if the delta H and delta V are positive value, then it is called as ideal, non-ideal solution with positive deviation. If delta H with the negative value, delta H and delta V together, if it is negative value or if it is decreased means, then it is called as non-ideal with the negative deviation. I hope you can able to understand. The differentiation is important here. You just observe the differentiation and the examples. I said you just compare the examples of ideal and non-ideal. They are easy to classify. How means you will come to know now. So here just you observe. So non-ideal solution with the negative deviation I have done, and this is positive deviation. I have taken again just to try it yourself. Okay. So in the negative deviations is nothing but the positive means the values partial pressure of the component A. This is the partial pressure of your component. This is XA mole fraction. This is the formula. PA is equal to PA naught into XA. Here, if the PA means partial pressure of the component should be equal to PA naught and XA. If it is having lesser number, PA is lesser than that of PA naught into XA, then it indicates that PA is having the lesser value than its another number. So it means that if the PA is lesser, this is comes in the negative deviation. The same thing here also. If the change in enthalpy, if it is negative, means decreases means it is also negative. If it is volume decreases means this is also negative. And total volume, it is negative is nothing but if the sum of volume, the component A and B together, they are not equal to the that of mixing value. Think that in ನಮ್ಮ ಕಡೆ component A ಇದೆ, B ಇದೆ. A volume 1 liter ಇದ್ರೆ 2 volume ಅದು 1 liter. So 1 liter plus 1 liter ಎರಡು ಆಡ್ ಮಾಡಿದ ತಕ್ಷಣ 2 liter ಬರಬೇಕು. ಆ ಮಿಕ್ಸ್ ಮಾಡಿದ್ರೆ 2 liters ಬರಲ್ಲ. It is less than 2 liter. So this indicates that individual volume of the A and B are together it is greater, but after mixing the component A and B, we are getting the volume is lesser. That indicates the negative deviation. So these are the differentiation or the definition you can write based on this one, and whichever it is we have shown the totally it is reverse in the positive deviation. Means here PA is greater than PA naught into XA. Here delta enthalpy is positive, delta V also positive. And moreover, I explained you to observe the examples of ideal and non-ideal. Just look here. In the ideal solutions, I have given the examples. Means those are having the same category. Means if I taken as a alkane means alkane, halogen means I have given the example for the halogen. So benzene and derivatives are changing. Benzene only, chlorobenzene or bromobenzene. Like that I have changing. Means examples are having the similar category, similar groups. That's why they are having the ideal solution. Whereas in the non-ideal, both positive and negative deviation, they are having totally different. Can you see acetone? It's a functional group of ketone. Whereas aniline is a benzene derivative. There are lots of different in the structure and the properties. And here methanol, methane, number of carbon atom is 1, and methanol is nothing but alcohol is there. Acetic acid, the functional group is acid. So functional group is different and the structure is also totally different. Means the properties also varies. So such kind of examples means here acetone and aniline together, this mixture is example for negative deviation. This is how we have to remember. If you have written only one example means it's wrong. Acetone plus aniline, this mixture is example for negative deviation. Similarly, acetone plus ethanol, ketone and ethanol, alcoholic compound. These two are the example for the positive deviation of non-ideal solution. So you have to remember, by observing some of the values, we can able to, first thing is we can easily able to understand ideal and non-ideal. One thing, and those are non-ideal which are containing positive and negative together. These are the example for non-ideal solution. Maybe a positive ideal or maybe a negative ideal. These two examples together, these all are example for non-ideal. When pressing this one means these are they probably they will ask you the ideal and non-ideal rather than positive ideal and negative ideal. So keep in your mind. So this definition and differentiation is important in this ideal and non-ideal. So look here, this is the last concept in today. Today we are having at the last, that is azeotrope. What is azeotrope? They will ask. So azeotropic are the mixture, these are the compound in which they are going to undergo the deviation in the composition. So by this deviation in the composition appears in the two way, that is by changing the temperature. Means here the distilled over without change deviation means solutions are do not undergo the changes in the totally compositions are not changing, means composition remains same, but they are undergo the deviation in the states. Means as the vapor pressure we observed in the ideal and non-ideal, means I hope in non-ideal positive deviation and negative deviation, how the deviation is appearing in the greater or negative values. Like that here they undergo the distillation, means transformation from one gases to the another distillation method. They undergo without change deviation in composition, means it means the composition remains as it is, the compound remain as it is, but they undergo the vaporization or converting the compounds are changing. If you want to change the boiling point, if you want to change the volume, it happens only in the different temperature. Means initially think that water is having 100 degrees Celsius of boiling point, and that 100 degrees Celsius can be increased, means it will easily changes to the gases in lower temperature, or sometimes it will take maximum temperature to deviate in a negative value. That can be calculated, that can be saved by the azeotropes. So here azeotropes are nothing but they undergo the deviations but without changing the composition. Composition remains same, but they undergo the deviation. Such kind of mixtures are called as azeotrope. In the azeotrope, we are going to classify again minimum boiling azeotrope and maximum boiling azeotrope. Means here we have these azeotropes we are going to boil at minimum temperature, and some of the azeotropes we are going to boil at maximum temperature. Why we are boiling that one means the condition is here, the minimum boiling azeotropes are nothing but they undergo the larger deviations. So it means they undergo the larger, and see here both are undergo larger deviation only, but here it undergo the larger positive deviation. Which one? The minimum boiling azeotropes are undergo the larger positive deviation in minimum boiling point. We are boiling minimum, but it is undergo the larger positive deviation. Such kind of azeotropes, such kind of mixtures are called as minimum boiling azeotrope. Minimum boiling azeotrope. The example is ethanol and water. This mixture is undergo at lower temperature. It can occupy the larger positive deviation. Are you getting this point? Similarly, the maximum boiling azeotropes are because these are the azeotropes containing two solutions. Those solutions, when you going to boil them at higher temperature, they also undergo the larger negative deviation. It's undergo the negative deviation when we are boiling them at maximum temperature. Maximum boiling azeotropes are undergo larger negative deviation in maximum boiling. Such kind of azeotropes are called as maximum boiling azeotrope. Here the example is nitric acid and water. These are undergo the negative deviation, larger negative deviation when we apply maximum temperature. So it means that some of the solutions are undergo negative deviation, some are undergo positive deviation. So to make it as a positive deviation, we need a minimum boiling. Such kind of isotopes are called as minimum boiling isotope. Here, to get the negative deviation, we have to increase it. We have to boil that compound in the maximum temperature so that we can get the negative larger deviation. The example for the positive deviation is ethanol and water. To get the negative deviation is nitric acid and water. These definitions here are sometimes they will be asked. So moreover, azeotrope and examples are important. To the example for azeotrope, we can add these two. These two are the example for azeotropic mixture. So I hope this is clear for you. If you are having any doubts in the explanation, you just ask me or text me. And don't forget to write the assignments and all. Be in regular So we will meet in the next class. So next class which we are having the some derivations are there. We are going to get the new different four different formulas. So based on that we are going to solve the problem. Definitely one different formula means one separate category problems are there. Those will be a fixed portion in your annual exam. So we will meet in the next week. Until have a nice day.